Thanks, Catherine, and hello, everyone. So let's get started. My name is Jean. I'm one of the co-founders of Linkurious, and today I'm joined by Thibaut.
Hello, so I'm Thibaut Kellum, and I'm head of customer success at Linkurious.
So let's dive in. First, a few words about Linkurious. The company was founded in 2013. We are a team of 50 plus persons with an office in France and another one in the US. And on a daily basis, more than 10,000 investigators throughout the world are using our products to conduct complex investigations around graph data. You can see here some of our clients, and that list includes organizations such as Zurich Insurance, HMRC, Pioneer, and more. So now let's talk a little bit about today's agenda. So we are going to tackle four topics. We'll start with the challenge of capturing context within data. Then we'll talk about unlocking context in data using graph. After that, we will explain what's the role of Linkurious in helping enabling contextual decision making. And finally, we will dive in a series of use cases, customer stories, and demos to show some concrete examples of use cases of graph technology. So that's it for today's agenda. And let's start with the challenge of capturing context within data. So first, the volume of data is both growing and also at the same time, the data that we are generating is becoming more and more interconnected. It's estimated that in 2023, approximately 120 zettabytes of data was generated. And it's not just that it's a lot of data, it's that this data is growing. In 2024 and 2025, the data has grown by 24% approximately. And this data, as I was saying, is becoming more and more interconnected. As an example, there's an estimated 75 billion of IoT devices out there projected to exist by 2025. And understanding the connections in data is really critical across several use cases. And here you can see some of those use cases, such as financial crime, intelligence, cybersecurity and IT, data governance, life sciences, and manufacturing. And in financial crime, it can be relationships across clients, transactions, phone numbers, addresses, bank accounts. In intelligence and law enforcement, folks are interested in relationships across people, transactions, email addresses, bank accounts, just like in financial crime. In cybersecurity and IT, the data can be a bit different. It can be routers, switches, vulnerabilities, servers, logs. In data governance, the data is yet again different. We can be discussing metadata, applications, servers, ontologies, and all of that is interconnected. In life sciences, people are interested in the relationships across entities such as drugs, publications, researchers, molecules, patients. In manufacturing, it can be relationships across products, suppliers, the bills of materials, and different clients. And understanding these different types of entities and relationships is really critical to unlock a lot of use cases. So once again, going through the various use cases the various domains that I mentioned earlier. So in financial crime, it can be related to know your customer, KYC. The understanding of entities and relationships can also be of great value when it comes to fraud detection, forensics analysis, or anti-money laundering. In intelligence, the use cases range from borders control to anti-terrorism and master data management. In cybersecurity and IT, use cases include networks, point of failures, and identification of systems resilience, kill chain analysis, root analysis, or configuration management. In data governance, we are seeing use cases such as computing risk exposure or risk compliance, data lineage, and master data management. In life sciences, the understanding of entities and connections can be critical for drug discovery and repurposing, for supply chain management and resilience, and to understand the patient journey. In manufacturing, the use cases can be Asset 360, Project 360, supply chain management, competitive intelligence, and more. This list is not meant to be exhaustive, and we will dive deeper into some of the use cases later. But just to give you a first understanding of the breadth of use cases when it comes to understanding the data and the relationships across various domains. Something else that I wanted to mention is that there's growing and increasingly interconnections in data, and this makes decision-making a lot more challenging. It's estimated that 92% of companies report that data growth and complexity is a real significant challenge in achieving their goals. 89% of businesses report facing considerable challenges in integrating data from various interconnected sources. And an estimated 50% of strategic decisions are missing crucial intelligence because organizations can't take full advantage of data. And one big driver for these issues is really that we are still relying on tools that were built for a less complex world. And here you have a bit of an example of that. It's a dashboard, and it can be very effective when it comes to making sense of trends such as how sales are evolving, how many incident reports have been generated in the last 12 months. When you are dealing with a couple of dimensions at a time, this type of analytics can do a great job. But for the more complex analysis of connected data, it's just not up to the task. And this means that there's also a price to pay with using outdated technologies and outdated tools. The first issue is performance issues. When you're using relational databases and generic NoSQL databases to analyze connected data, you're using technology that was simply not designed for the analysis of large-scale graph data. So it means that finding complex patterns, indirect relationships, identifying communities is just not simply going to work at scale. The second issue is the issue of blind spots. So maybe you want to understand the ripple effects of disconnecting a server. You want to understand the indirect relationships of a client with a sanctioned entity. Unfortunately, too often the connections in your data, they remain hidden until it's too late, until you discover that indeed you are exposed to a sanctioned entity, or that indeed there's an indirect effect to disconnecting this server that you hadn't anticipated. And finally, all of that translates into operational costs. So it can be detected fraud schemes, slow investigations. Ultimately, the difficulties with understanding the context within your data, it translates into real costs. And that's why there's a need for tools that enable context-based intelligence. Tools that provide contextual understanding, that provide the ability to integrate various data sources, and tools that can scale in terms of performances to today's large, complex connected data sets. So we've talked a little bit about the challenge of capturing context within data, and now I want to talk about what tools are there in terms of helping organizations make sense of complex connected data, and specifically the value of graph analysis. So there's a whole field called graph analytics that has developed and that is really booming and which helps make sense of complex connected data. And I'm going to talk a little bit more about graph analytics and what it means in practice and how it can be applied to various problems. But first, what is a graph? So here on the right, you have an example of a graph, and a graph is really just a network. It's a group of nodes and edges. And a graph can show relationships, dependencies between entities, and you have an example of such a graph on the left, on the right, sorry, with, for example, up top, a node representing a company called Linkurious connected to a person called Daniela. This person, Daniela, being connected to Paul, who himself is connected to the company. Within a graph, there are nodes. A node is really a way to represent an entity in a graph database. It can be a person, a company, it can be a bank account, a contact, a phone number, an address. And here in this context, the nodes of the graph are presented as circles. In a graph, you also have edges. An edge is really a relationship between two nodes. It indicates the link that exists between these two entities. And edges, in this context, are represented by arrows. And you can see in blue highlighted an edge, and that edge represents the fact that Paul and Daniela have a node relationship, meaning that they know one another. And finally, when we're talking about graphs, there are also properties within a graph. And property is really a piece of information that's attached to a node or an edge and gives details about this node or edge. So here we have a property which is the position, and that property has a value which is CO. So Paul works for Linkurious and has the CO position within this company. So that's it for a quick primer on graph and the main concepts. Now I want to show some concrete examples of how to apply that in practice, starting with a cybersecurity example. And here we have a cybersecurity graph. So we have modeled the data from the cyber domain as a graph, and we can see that we have users that are connected to endpoints such as a mobile app, web app, desktop app. These endpoints can be connected to wireless access points, mobile network, wireless access points, and connected to switches, firewalls, databases, and more. And really, here, via the graph, we are able to express the data that can exist in cybersecurity. So that's one first example of modeling data as a graph in the cybersecurity domain. But it's also possible to represent data as a graph in anti-fraud. And here we have such an example. So we see some persons, such as synthetic person number 2, account holder 1. We also see entities such as phone numbers, social security numbers, credit card, bank accounts. And all of this data is modeled as a graph, as we can see on the right, and this helps reveal that some of the account holders, some of the persons are connected to one another. It's also possible to model data lineage as a graph. Here we have such an example. We see that we have a piece of metadata that's associated with a system that flows into a process, is transformed into another piece of metadata stored in another system that then goes to another process, becomes another piece of metadata, and ultimately ends up in a report. So here we are really modeling data lineage as a graph, and it helps understand the context where the data of the report, for example, is coming from. And it could also be helpful to answer questions such as what would happen if I was to make some changes to one of these processes or remove one of the systems in the data lineage graph. Here is an example of applying graph thinking to supply chain, and we can see that we have some product data that's merged with supply chain data, customer data, event data, and more. And we see, for example, that we have a product on the left that's connected to sales figures, sales forecasts, market data, and more. That product is connected to an assembly that's connected to a component that exists in various facilities. And this supply chain graph can help answer questions such as what would be the impact of an incident in facility X or Y. if there's an issue with product, either with a given product, it's also possible to understand where the issue can come from, and more. So we have seen how to apply graph thinking to various domains. And what's interesting is that there's really a toolbox of algorithms in graph analytics that can then make sense of this connected data. And here you have an overview of some of the popular types of graph algorithms. So it all starts with pathfinding. So pathfinding graph algorithms can help answer questions such as what's the shortest route for shipment in my supply chain. There are also centrality algorithms, and centrality algorithms can help answer questions such as who is an influencer or gatekeeper within this particular network. There are also community algorithms, and community algorithms can be used to answer questions such as, is this money laundering part of a larger network? There are also link prediction algorithms to answer questions such as, are these two clients likely to know each other? There are also similarity algorithms. Is there a criminal network with a structure similar to this one? That's the sort of question that can be answered with these algorithms. And finally, there are also embeddings, graph embeddings, which are really a way to turn contextual data, graph data, into a machine learning friendly input. So these are various types of graph analytics algorithms. And then there are, in each of these categories, there are different algorithms, and I'm not going to go through for each one, but for example, when it comes to centrality, there's the degree centrality, the closeness centrality, the PageRank algorithm, and more. When it comes to computing communities, you can use the kinetic components algorithm, the label propagation algorithm, or the Louvain modularity algorithm. So these are some of the tools that are available via graph analytics to make sense of data once it's modeled, when it's thought of as a graph. And something that's important to understand is that once we are working with data stored as a graph, once we are trying to apply graph analytics to this data, then graph databases really quickly become critical. Because graph databases have been built from the ground up to store and analyze connected data at scale. If you have simple questions when it comes to the connections in your data, maybe you're just interested in what's going on about a particular entity 1 or 2 apps away from it, or maybe you are dealing with graphs in the low thousands of nodes and entities, then virtually any backend can be used to analyze the data. But as the complexity of the questions, as the volume of data scales, if you're using relational or traditional or other NoSQL databases, then very simply the response time is going to increase very quickly in a non-linear fashion. And you can see an example of that with the blue line there. Whereas if you are using graph databases, then it's much easier to run this type of analytics, and you can run them at scale, dealing with graphs in the billions of nodes and relationships, and traverse tens of hundreds of nodes if need be to run your analytics. So that's really why graph databases are very critical when it comes to applying in practice the analysis of graph data. Something that's also important is that making sense of the complexity in data can also be unlocked with graph visualization. So we've talked about the various graph algorithms, but graph visualization is very complementary when it comes to making sense of graph data. And here we have a very simple illustration of that. On the left, you have a table. And if you're trying to make sense of the relationships that exist within these tables, maybe you are trying to track how different persons are interconnected to one another across PIA. it's going to be difficult to make sense of that, and you will probably end up with various tabs open in your laptop, and not a very easy time, I guess, to get to the bottom of your investigation. Whereas when this same data is plotted as a graph on the right, very quickly, very intuitively, you can see all the various entities are interconnected, and you can start answering questions such as, are these two persons connected somehow, and what's important or in the network or not. And one thing that I want to stress here is that there's really, graph analytics is really a journey, I guess. You can start very easily with graph visualization. Maybe you have some data and you simply want to visualize that as a graph, and you can already unlock a lot of value and accelerate investigations. And then it makes sense to start detecting several patterns within the graph, for example. So it can be using graph patterns to score entities and to detect suspicious patterns. And then finally, you can apply graph data science, and that means applying the algorithms from graph data science, the algorithms that we mentioned earlier, and can help improve the detection of risks and insight, just like it can help improve existing machine learning models. So we have talked about the impact, the potential of graph analytics, graph visualization, and now I would like to talk about how Linkers Enterprise or flagship product is really helping put that in practice. With Linkers, it's possible to get better and faster decisions via a product that we have built. It connects to various graph databases and provides a very simple UI for which teams of investigators and analysts can both detect insights hidden in graph data and also conduct investigations. All of that in a collaborative and secure environment. And you can see a screenshot of the platform on the right. So how does it work? It all starts with data, could be internal data or external data, and the data is streamed to the Linkers platform, where there are various functionalities that are applied, so that ultimately it's possible to make context-based decisions faster and more accurately. These various building blocks are entity resolution. So we are applying entity resolution to fuse various data sources and help identify when different records are actually related to one and the same entity. There's also the use of AI in graph analytics to enrich the data, and then alerts and case management and search and visual investigation. So why Linkers? Why this platform is being trusted by the various clients that I mentioned earlier? There are 4 big reasons here. The first one is better decisions. With graph visualization, it's possible to understand the context around any situation and use that to make the right decision. There are also entity resolution capabilities that help improve the quality of data and ultimately the decisions. And finally, with comments, shared spaces, and advanced collaboration features, it's possible to work collaboratively on the decision-making process. Another critical point is the ability to detect risks with the use of Linkers. So it's possible to go from graph query to alerts and scores in minutes with the software. There are also capabilities around case management. And finally, it's possible to use the graph algorithms that I was mentioning earlier, but also node embeddings to detect and enrich your data. Finally, there are two other aspects that are important: the flexibility of the platform and the fact that it can scale and match the needs of large organization. So in terms of flexibility, we provide an API, a modular architecture, and an open data model, which means that no matter the use case, no matter the context, it will be possible for your organization to apply linker use to your graph data. And finally, in terms of enterprise readiness, with the ability to scale to billions of nodes and relationships, the ability to manage very finely access rights and secure the data, and the fact that it's possible to deploy the platform on-premise or in the cloud, it's very easy to work with the platform, even in challenging contexts. Now I want to zoom in on some of the capabilities that I mentioned earlier, starting with entity resolution. So first, we are leveraging AI to deduplicate different data sources and generate a unified knowledge graph. So that's really where the value of entity resolution comes in. And what's interesting here is that it helps organizations extend their internal data with trusted third-party data sources, such as Dun & Bradstreet, Moody's, Open Corporates, and more. Ultimately, this can help better understand clients and their counterparties and facilitate the identification of risks related to politically exposed persons, compromised endpoints, sanctions, and more. In terms of AI and graph analytics, the platform has direct compatibility with the leading graph databases, such as Neo4j, AWS Neptune, MemGraph. And through that, it's possible to explore and analyze data sets of billions of nodes and edges in real time. And via these integrations, we also provide support for more than 70 graph algorithms, including community detection, node bindings, PageRank, and more. And it's possible to use that for context-based scoring and for the detection of anomalies within graph data. The alerts, engagement, case management capabilities in Linkers Enterprise are also very helpful because it allows users to go from graph query to alerts in minutes. Within the UI, it's possible to manage various cases. You also have access to email notifications and comments to collaborate on those cases. We are also using graph analytics to deduplicate cases and reduce the workload. And finally, all of these capabilities can be integrated in other case management systems via webhooks. And the final piece, and not the least important, is that within the Linkers platform, you have access to search and visual investigation capabilities. So you can visually explore and investigate graph data. It's possible to display thousands of nodes and relationships. And with various features such as geospatial layout, the timeline, the ability to group nodes and relationships, it's possible to make sense of data, no matter how complex it is. And finally, it's possible to turn complex investigation workflows into patterns and forms to accelerate these workflows. So we have seen how the Linkers platform helps really apply the full power of graph analytics and graph visualization. And now I will pass the baton over to you, Thibaut.
Thank you, Jean. So indeed, now let's deep dive a little bit more into the different use cases and the different customer stories that we are lucky to be, that some clients have shared with us. Regarding demos, actually within the handouts, you indeed have different links to recorded demos. So indeed, we're not going to have time to do specific demos for each use case that will be present in there. So offline, feel free to look into the handouts and look the demo that corresponds to the industry you're working in, whether it be supply chain, cybersecurity, email, or fraud. So on that note, let's start and let's see. I'm going to first start with cybersecurity. So indeed, cybersecurity is one, I would say, an iconic use case for graph technology for two main reasons. The first one being that typically we say that attackers think in graph, meaning that they're always looking for the shortest path to the most strategic assets within an organization, for example, whereas defenders think in list, meaning that they're have a list of application logs, for example, and the consequence is that they're less, I would say, agile than attackers. Another reason for that, why it's so successful, is that graph technology allows to really build what we call a digital twin of an IT architecture and an IT network, which is the most intuitive, in fact, of visualizing, exploring, and understanding an IT network with key components such as applications, software, hardware, servers, databases, software bill of material, crown jewel assets, for example. And this digital twin of the physical architecture of a company serves kind of like a canvas that can serve many use cases. For example, from this digital twin, if you add, for example, connections and build connection with access and application logs like IP address, users, software vulnerabilities, known attack types, network traffic, you can serve different types of use cases. Typically, the first one being, for example, vulnerability management. And one of the questions you can ask the graph is which systems are running unpatched software and how are they connected to high-value assets. You can also deep dive into privilege abuse detection, such as which users have gained abnormal access to sensitive data, and are there any suspicious access patterns. Another example could be malware propagation, with a typical graph query that would be which files or application have been accessed by multiple devices, and are there any link to known threats. So if we look into a customer story around cybersecurity, the first one, or the one we can put forward, is a client of ours that is a global aircraft manufacturer, and indeed a very complex organization with complex processes and high sensitive projects and highly protective assets and data. And they had roughly 17 data sources to integrate, covering different aspects such as business processes, servers, bill of materials, and a team of users working on digital security risk and asset management. The challenge they were facing is that because of those complex processes and different data sources, and they really were lacking a synthetic and complete view of risk management to do, for example, IT resiliency. So if a server goes down, what are the downstream impacts, but also cybersecurity, but also IT optimization. Do I have redundancy? Can I, for example, decommission a server and have a more optimized IT architecture? So they needed a tool to enable cyber risk analysis. For example, to provide elements to support risk analysis, produce simulation, and generate threat alerts, but also provide visibility on impact of technical vulnerabilities on business processes. So why did they go with Graph? First of all, in order to establish a single and exhaustive enterprise-wide referential in terms of exposure to cybersecurity vulnerabilities. So and you can see here a small extract of the type of graph that they were able to build, meaning that first of all, they built their graph mapping or connecting the business processes downstream to the applications that are used for those business processes, the hardware and the servers that supports this activity. And then they integrated that with a publicly list of cybersecurity vulnerabilities that is called the Common Vulnerability and Exposure Glossary, that is produced by the NIST, the National Information and Security and Technology in the United States. So you can see here a mix within internal data and external data, and they were able to map those CVEs, vulnerabilities, to internal hardware application and business processes. So the idea is that they had a way to visualize directly dependencies between, for example, vulnerabilities such as abuse of rights, system intrusion, and really concrete downstream effects on their production. They can also, in just one click, run some cyber attack scenario. So have some simulations, like typically, if I'm working this business unit, what is my main exposure in terms of a cyber threat? Where do I need to reinforce, put the most security, for example, and really run those simulations. So that was a first use case, and I really encourage you to, in the handouts, look into the cybersecurity webinars and demo if you want to have it, see it live and how it looks like concretely in Linkers Enterprise. But now I want to deep dive into a second use case, that is retail banking fraud, which is one of the many use cases within the, I would say, anti-financial crime domain. And indeed, fraud is a very successful use case of graph technology, if I must say, like an iconic use case. For one obvious reason is that fraudsters work in network, which allows them to be more agile, to reuse, switch identities within the network, and run, for example, simultaneous fraud attempts, to get to test the KYC processes, the credit approval processes, and rules and engine of banking institutions, and really maximize their the opportunities. So, of course, if you speak about network, you speak about graph. And typically, what are the type of data that you would see that you could put as a banking institution within a graph? Well, you will build a graph typically with customer PIIs, but also digital fingerprints like IP address, the type of device, the device that is used to access the banking application, for example, companies and company details, beneficial owners, directors, bank accounts, credit requests, loan applications, also transactions, and OSINT data such as social media profiles, but also, for example, say blockchain logs data, for example, that could be used within a graph. The common use case for retail fraud investigation is, well, detecting first-party and synthetic identity fraud. Typical questions that queries to the graph would be, for example, which credit requests are connected through shared PIIs, indicating potential synthetic identities or large-scale fraud rings. Account takeover, which would typically be identified by showing suspicious behaviors of bank accounts or banking application logs, which showing like unusual timeline of logins, the number and the geographical localization of IP address that are used to access a banking application. And link prediction for future fraud detection is also very interesting, which allows to be more proactive in identifying, well, entities that are likely to be involved in fraudulent activities based on historical patterns and existing relationship to known fraudsters and fraudulent communities. Let's look into a customer story, and this time we have a EMEA digital bank that specializes on consumer lending, namely short-term loans, so providing short-term loans such in buy now pay later services and credit card services. So the bank provides its service to 100K retail clients in Europe through a network of partner merchants. The challenge here is, like many banks, is that the financial institution is exposed to first-party fraud, synthetic identities, identity theft, account takeover, clients. So many individuals reusing a set of synthetic identity to obtain short-term loans and, of course, never pay it back. So fraudulent networks evolve quickly and are able to adapt their techniques to the bank's risk detection rules. And they were looking for a proactive and at-scale solution to detect and analyze large-scale fraudulent networks for both what they would call decision-making, real-time on new credit requests, and cold case investigation to better understand how they have failed and how they can vaccine their models upstream. So this is typically represented as a graph, the kind of challenge that they're exposed to in their daily business processes, meaning that, for example, you have, and read, as the note read, some credit requests that were already refused because well, they showcase some signs of fraudulent behavior. And some are connected to pending credit requests to the same credit card, like the credit request number D, and some by sharing the same IP address. So you have those connections. Which ones are a red flag and should be a sign that we should refuse the credit request? Which one are a normal type of connections and indicate that possibly we should approve the credit request? So bear in mind that this decision needs to be taken in near real time. And here you have it as a small subgraph, but just imagine have that across thousands and thousands of communities of clients' credit requests, PIIs, that really complexifies the analysis and the need to yet still take decision in a very short amount of time. So indeed, the solution, well, the main challenge is, well, to detect large-scale communities of credit requests connected through PIs and digital footprints. And they made very good use of community algorithms, like the one that Jean showed in the previous slide from the Graph Data Sciences library of Neo4j, for example. And the fraud team was able to enrich their graph with new relationship produced by those graph community algorithm, highlighting the similarities between multiple credit requests, so same email, phone number, address, building networks of potential fraud that can be exploited and flagged in link areas. The impact is that the combination of graph data science and link areas significantly improved the ability to quickly and effectively make the jump between isolated fraud and large-scale communities of fraudulent credit requests. So not only take better decision on pending credit requests based on graph scoring, but also identified where the system upstream have failed because, well, there were some approved credit requests that showed connections to fraudulent credit requests, and where they need to strengthen their detection rules, for example. So a significant also increase in terms of the amount of avoided fraud, a decrease of time spent on analysis of fraudulent communities through linkers, enterprise alerts, and visualization. And also, interestingly, an increased knowledge of evolving fraud patterns, indeed, because when you see fraud through the log scale picture and not just only isolated fraud, you get a better knowledge of how networks work, how they evolve, the new techniques that are being used, the ones that are kind of like outdated. Where should we be more agile? Because, and well, thanks to this large-scale analysis that graph technology allows. Kind of in the same, I would say, domain, but still a different use case, and a very common use case for graph technology is in-time money laundering. And one of the main pain points of in-time money laundering investigation today is indeed the limited view around clients, transactions, bank accounts, companies that compliance and intelligence teams, anti-financial crime teams face, and the reliance on rules and thresholds to take decisions, which is sometimes a very limited context to take a decision on possibly very complex money laundering networks. So it's no surprise that graph are such a fit for in-time money laundering investigation, as it allows really to get a holistic 360 view around bank accounts, as I said, but also companies in complex, sometimes ownership structures with offshore shell companies, around transactions, and get really the full context to be able to have a real holistic, exhaustive analysis of in-time money laundering patterns. So the data here is very similar, I would say, to the fraud investigation, in the sense that it relies on customer identities, personal details, transactional history, and digital footprint, corporate structures such as companies, subsidiaries, shell entities, and offshore accounts. If you're looking into, for example, sanction evasion, politically exposed persons, and their relationship to, for example, offshore accounts, shell companies. This is very important. And of course, also transactions to follow like the money flows investigation, follow the money investigation through graphs. The common use cases, well, identifying connections with politically exposed persons, such as which companies or accounts are indirectly linked to PEPs or sanctioned entities, detecting money muling patterns, following suspicious money flows, so which accounts are involved in suspicious money flows that span multiple jurisdictions, and how do these transactions connect to known risky entities. A success story that we have on AML with Linkurious is with a company called Ria Money Transfer, which is a leading money remittance company generating $1 billion roughly dollars in revenue, operating in more than 165 countries, available via retail and digital channels. And the tool Linkurious is actively used by more than 100 analysts and compliance officers daily. The challenge is that they had an existing scoring and case management system based on legacy AML software. So thresholds in terms of identifying money corridors and transactions, but purely based on rules, I would say, and whether or not a specific transaction goes across a specific threshold in a short period of time, for example. But this is where they were still vulnerable against complex schemes such as round tripping, money mules. And once they detected a suspicious transaction, it was very hard to get the full picture around high-risk customers and really understand all the stakeholders involved in a specific money corridor. So the solution was the combination of, interestingly, keeping their legacy AML solution, but enriching it with Linkurious and Neo4j, using the alerts in Linkurious to detect complex graph patterns, and pivoting from the existing legacy or enriching their existing legacy AML solution with Linkurious to conduct investigation, reduce the investigation time for complex cases by 80%. And it's a very they made like use of all the all features of Linkurious Enterprise and advanced features to really get the full experience around AML investigation. So here I'm quoting the compliance director and the project manager, the one who really spearheaded the graph project at RIA, who I'm quoting, said, "We are able to now identify patterns in ramification of unusual transactions that were impossible to achieve via a traditional approach." Last but not least, supply chain analysis. Today, like whether we're talking about products, suppliers, companies, every part of an organization is part of a wider network, meaning that it's making them ever more vulnerable to external disruptions such as climate change effects, geopolitical risks, pandemics, for example. And we see that it's very easy to disrupt a supply chain organization. And well, graph technology really helps organization have a better management of their supply chain, identifying the weak points, and at the end of the day, make their supply chain management more resilient and more robust. How it would work typically and what kind of data you could find in the graph for supply chain management purposes. Well, you would get organizational data, such as documentation, process, the different facilities, product data. So again, the software bill of materials, the different parts, components. You would get also third-party data, social media, market data, company registered, supply chain data, customer data, such as customer preferences, order histories, and delivery patterns. Some of the use case around supply chain are around what we call PLM, product lifecycle management. So what are the relationships between suppliers, manufacturers, and distributors, and how do they impact the life cycle of a product? Risk management. So where are the weak points in my supply chains that could be affected by external disruptions, such as geopolitical risk or natural disaster? The case study or the client testimony here, success story that I'd like to highlight is one still from a global aircraft manufacturer that indeed, as such a complex organization, manage an international networks of suppliers and subcontractors related to the various parts, process, and components of the industrial process and the final products that they build and sell. The challenge is that they had more than 100K supply records across 3 different business divisions, and it's a very complex task to monitor and update the hierarchy of suppliers between mother companies, subsidiaries, companies that no longer exist, beneficial owners of the companies that change, directors that change, and still monitor that with their specific risk score and geographical distribution. So they were really struggling to have a clear view and a clear map, including competitor supplies network, to really identify and manage the dependencies. Typically, if an organization, you would think that you have a wide different number of suppliers, and that you're diversifying your exposure to failure of suppliers. But if indeed they are related to the same mother company, well, where you thought you had a risk that was diversified, indeed you're exposed to the same risk of a company failure, supplier failure. So the solution that they found is, well, build a graph database with supply data coming from their purchasing departments, but also enriched with third-party data on companies, with UBOs, credit score provided from companies like Dun & Bradstreet, for example. Build and visualize that hierarchical structure of supplies with geo-coordinates, and integrate linkers with their existing BI tool to provide business with a consolidated 360 view of the suppliers and their relationship with the head companies. The impact is that they were able to identify key and critical suppliers, which in turn helped them in decision-making for the purchasing strategy, when doing call for tenders, reduce the purchase price when renegotiating the specific contract of a supplier, make faster event impact analysis, identify the risk of delayed delivery, lockdowns, incidents, failure of a supplier, for example, and run competition analysis. In that case, identify quickly alternative sourcing options to minimize their exposure to a specific number of suppliers. So these were the four for the different use cases that I wanted to present. Again, don't hesitate to look into the handouts for the actual demos in Linkers Enterprise to have more details and see how it works in actions within the Linkers UI. And well, for the rest, we'll gladly welcome any questions. And and happy to answer them.
All right, thank you, Jean. Thank you, Thibaut. I see we already have some questions in the Q&A panel. If anyone has other ones they'd like to drop in, it's not too late. We'll have a few minutes left to answer them. So let's start with the first one. How do you bring external data into Linkurious?
Jean, you want to try with this one? I can complement it.
Happy to. Happy to. So the various graph databases that we support have each of those have their own set of connectors with integrations with tools such as Kafka, RDMS databases, and more. And basically, our clients typically use these connectors to import the data in one of the graph databases that we support, and then Linkurious itself is connected to the graph database, meaning that once the data is in the graph database, it's accessible via the Linkurious Enterprise UI, and via Linkurious, we can also perform some entity resolution to make sure that the data that's in the graph can be deduplicated.
And if I may add, directly in Linkurious also UI we have a very cool plugin that allows you on the spot to bring external data from a company node, for example, and enrich it from data from company registers. So you can also with Linkurious do it directly in the UI at the user level.
All right, thank you both. So here's another one. It looks like Linkurious might be a good solution to complement some of our existing tools. How easy is it to use Linkurious alongside other tech?
I can start, Jean, if you want. So the main integrations that we see are usually, we have two cases. The first one are client integrating it with their existing BI tools, which serves a good purpose because it allows kind of like a combination of best of both worlds. So you would have like the Power BI, Microsoft Power BI dashboard, and through what we call deep links and integration, you can open a visualization directly from an entry point in your BI dashboard. So that's one of the main integration. The second one is, I would say, with risk management tools. So a kind of like a typical tool in the AML industry is kind of like a nice Actimize, those kinds of tools where they produce the rules. And from the results, you can jump into Linkurious Enterprise to have a more deeper and exhaustive investigation. So these are the two main integration, I would say, BI tools and risk management tools. Jean, you want to say something else?
Nope. Perfect.
All right, thank you, Thibaut. Here's the next question. How long does it take to implement Linkurious?
So typically what we see from in post sales is that clients would be able in just 1 month to evaluate for free Linkurious. It can be on dummy data, it can be on a sample of company data, for example, but it allows them really to get the look and feel and kind of like have the first wow effect of graph technology. Then what we see is that within 2 months, 2 or 3 months, clients are able to run POCs on their company, their real data on like a more isolated environment, but really able to onboard a bit of the business users, have them also experience Linkurious with their data. We've seen also clients within 4 or 6 months being able to put their POC into production or pre-production, I would say, but also start experimenting a real flow of data updates and connections to their real data sources. And typically what we would see is that most of our clients within a year, they're able to have a fully in production industrialized solution with production data, onboarded users, and business outcome in terms of ROI. So that's kind of like the typical journey. Of course, it all depends on the complexity of your data, the number of users you want to onboard, the complexity perhaps of the use case. But yeah, these are the ballpark estimates that I can provide.
All right, thanks so much, Thibaut. So another one is someone's asking, saying they'd like to get more information about the use of Linkurious around data governance. Can you help?
Sure. So in this presentation, we try to give an overview of the various use cases. Obviously, there are more use cases, and it's possible to go even deeper into each of those. The best way to do that is really to reach out. It can be as simple as dropping an email at contact@linkurious.com, and we will be happy to share more examples of what we're doing with clients in data governance or in other use cases.
Thank you so much. I see we just have a couple more questions. So are there other use cases that you've left out of the presentation?
Sure. Again, the idea was to give a bit of an overview and not necessarily be exhaustive. So, for example, we are also seeing the use of graph technology in recommendation engines. It doesn't really involve the use of any graph visualization per se, but graph technology can be great for these sort of use cases. just like there's more and more interest around the use of graphs to ground LLMs and to enable generative AI use cases.
Perfect, thank you. And one last one. What are the different graph database providers that you support?
So right now we support really the leading graph databases out there. So we have connectors for memgraph, for AWS Neptune, Neo4j, and Azure Cosmos DB. So these are the connectors, and I think they are fairly representative of where the market is going, I guess, in terms of graph databases.
Perfect, thank you. So that's it for today. Thank you so much for everyone who joined us. We will be sending out the recording, so if you missed anything or you want to rewatch any parts of that, you'll have that in your inbox shortly. And that's it. We'll see you for the next one. Thank you. Bye-bye.
Hi, everyone. Thank you.